The method anywhere in the world, no method is perfect. No model is perfect. I've said it from day one. You know, a model, we're using a model is a mathematical or statistical representation of reality. Or we say simplification of reality. Look at that. I'm simplifying reality. And I know reality is complex. Simplify reality, there's always going to be a penalty that we're going to pay. And it's going to be error. Our statistical models are beautiful. You know why? Because we got some criteria to check whether our models are fantastic or not. And those criteria are what we call model, you know, the one that has to do with the model fitness and model complexity. Okay. And let me also tell you this. According to George Box, okay, according to George Box, you know what George Box said? He said, if you ask a question, how truth is our model? How truth is our model? If you mean complete truth, then our model is not true. Our model cannot be completely true. And that was why the George Boss said, all models are wrong, but some are useful. I'm going to say that again. George Boss said, all models are wrong, but some are useful. Now, do you know those that are useful? Okay. I'm going to write that. He said, all models are wrong. Okay. George Boss said, all models are wrong. Okay. But some are useful. According to George Boss, do you know some that are useful? There are some that we have validated. Those ones that are useful are those ones that assumptions met. Okay? So the fact remains our model can never give exact reality. And that's why all assumptions revolve around the error time. You know, but I'm going to reframe this. What George Boss said, that I'm going to say, quote me anywhere in the world. I'm going to say all models are wrong, but we can make some safe and useful. I'm going to say that again. I'm reframing this now, what George Boss said. And I'm going to say all models are wrong, but we can make some to be safe and useful. How? By having a very careful thought about how to, use an appropriate model for a given situation. Do you know why we normally run into a problem, right? When we are using, for instance, the true relationship supposed to be linear, and I use nonlinear. That means you are using a complicated model for simple relationship. You're actually going to mislead. There will be a violations of assumptions. Or instead of me to use a nonlinear relationship, and I use a simple linear, I use a linear because of simplicity. If you, because of simplicity of a model, and you use that for a complicated relationship, your model will underfit. If you use a complicated model for simple relationship, your model will overfit. Overfitness is as a result of having a lot of variables in your model, even though I know the intention of the scientists, of people in the scientific community. They basically want to, reduce bias by adding so many variables in the model, but in a way, they create another problem of the variance. And what we need to do to make our model to be safe, okay, and fantastic is when we ensure that we use the right model for appropriate model for a given situation. What is the takeaway? There should be an agreement. If I want to model a state of nature, I need to use a model that commiserates with the state of nature. But you know the problem we have sometimes? Some of us have rigid mind. Some of us in the scientific community. You know why we have rigid mind? We use the same model all the time, forgetting the fact that we're in a dynamic world. Things are changing. When things are changing, any attempt to use a static model for a dynamic situation will never stand the test of time. And that is the reason why we got to make sure our model is also dynamic. When situation is dynamic, we should be flexible. That is what I mean in our model. Any question, whether in person or online?